So today we'll see how to analyze any circuit, any quantum circuit using Qiskit. So for that, let's take an example of 2-qubit quantum circuit where the first qubit, this is the first qubit, and this is the second qubit. So firstly, we apply Hadamard gate to the first qubit, which is followed by the output of this is followed by a C controlled NOT gate, right? We all know this. This is a controlled NOT gate. So it will be followed by the controlled NOT gate. So let's first write, and for this we will further simplify this circuit a bit. We will take a particular case where our Q naught is in 0th state and Q1 in the 1 state, state 1. So let's first write the all the or the composite states at each step, and then we will analyze this using the Qiskit. So first composite state or the initial state is ket 0 tensor with ket 1, which we also write like this, right? Then the second composite state, what we are doing, we are applying Hadamard gate to the first qubit, and we are applying identity to the second qubit. So this is the notation which we use for that. We all know that when we apply 0 to 0 state to the Hadamard gate, what we get? A superposition state, right? With equal probability. So this is our phi 1 would be further written as 0, 1 plus 1, 1 by root. So this is the composite state at the first step. Similarly, in order to evaluate the second composite state, we need to apply a C naught, and we all know that C naught is a 2-qubit gate, right? So we can write it like that. We are applying C naught to the 2 qubits over the 2 qubits. And what is the characteristic of a C naught quantum gate? That when your control bit is 0, it does nothing to the target bit or the second bit, and but when your target bit control bit is 1, it flips the target bit, right? This is a control bit, this is a target. So first state will remain changed. However, the second term will become 1, 0. So the output of this circuit, quantum circuit, will be this. That it will have only two possible states, 0, 1 and 1, 0, with amplitude 1 by root 2 and 1 by root 2. So let's analyze this circuit using quantum. So what we are going to do here, we have written a script for that. Here we will install all the packages and import the libraries. And next we will start the creating the quantum circuit. And since our quantum circuit is a 2-qubit circuit, right? And when we are measuring this, we are storing it in the form of a classical bit. For example, this. So we are measuring it, right? So we will save it to a two bit, two classical bits. So we start like this, and then the first qubit we provide Hadamard gate, right? Then for the second qubit we have given HGH. So let's understand that why we have done that. So what is the property of the Hadamard gate of the Qiskit is that it start with default state is get 0. So in order to convert it to 1, since our in our circuit we have said that our second qubit is 1. So if we apply this, we will get 1, and we'll see how. So if this is the 0th state, if we apply Hadamard to it, what we will get? A superposition state. And when this state is applied to Z gate, what it does, it flips the phase of the 1, state 1. And we all know that this is a minus state, and when this is applied to the Hadamard gate, you can also solve it. I mean, it's not it's trivial to see. You will get a 1. So that is why I have applied first Hadamard gate, then followed by a H gate and Z gate, and then H gate. So it will give you a 1 to the. Now we have to apply a controlled NOT gate to both the bits, and this is the code to the recover or the find out the amplitude of each basis. This is the command for drawing the circuit. So next, our aim would be to simulate it, to run it, right? So if you run it for 10,000 times, which we controlled by this, you can change it. Around 5,000 times, we will get 0, 1, and around 5,000 times, we will get 1, 0, right? So in order to show that, we will draw the histogram and also print the count. So let's do it. So for that, I have already installed the Miniconda, and all the packages etc. are also already installed in a virtual environment. So let's run it. So as you can see that this is our original circuit which we want to analyze. And if you see that there are two states with amplitude 1 by root 2 and 1 by root 2, and 0, 0 and 1, 1 is 0. And as also you can see the histogram, the 0, 1 state is almost 5,000 and 1, 0 is almost 5,000. One more thing is worth mentioning, that in our analysis, or when we do analysis using pen paper, we write like this, right? That this is the first qubit and this is the second qubit. However, when we store this using, I mean, in Qiskit does like this. It first write this bit and then this, because it follows the MSB LSB rule. So when your Qiskit gives 1, 0, you need to understand that it is using your pen and paper notation is actually 0. So that's it. Thank you.